Hi everyone, today we'll be looking at the January 2019 P1 paper. Question 1, we need to carry out this integral here. So the first thing to do is actually write things in a form that will allow me to integrate. So that will be 1 over 2x to the minus 3. And now I'm ready to start integrating. I increase the power by 1 and divide by the new power. Similarly here, minus a half x to the minus 2 over minus 2 plus 5x plus c. Do not forget the constant of integration. We need to simplify the answer, so the 2 with the 4 leaves me a 2 here. So I've got a 6th x to the power of 4 plus a quarter x to the minus 2 plus 5x plus c. It's okay to leave these with a negative power. I'll be simple enough to score the full marks in question 1. Question 2, we need to find y is a simplified function of x. So we'll be using the rules of indices here. We know that when we divide with a common base, we subtract the indices, and therefore this will be 3 to the x minus 4y is equal to 27 is 3 to the power of 3, and root 3 is 3 to the half. So 3 to the x minus 4y is 3 to the 7 over 2 because I have added the 3 with the half. And now that I've got a common base, I can equate the indices here, which leads to x minus 4y is 7 over 2. I will multiply everything by 2 to get rid of the fractions. We're trying to make y the subject here, so 2x minus 7 is equal to 8y, which leads to 2x minus 7 over 8 is equal to y. Question 3, we've got the line L1 for which we need to find the gradient. Well, in order to see the gradient from the equation, we need to put in the y equals to mx plus c form. So 5y is negative 3x plus 7. Dividing throughout by 5 gives me y to be minus 3 over 5x plus 7 over 5. And therefore, the gradient is negative 3 over 5. In part B, we've got the line L2 being perpendicular to L1 and passing through 6, negative 2. And we need to find the equation of L2. So I will start by saying that the gradient of L2 can be derived from the gradient of L1 because we know that if two lines are perpendicular, then the product of the gradients is minus 1. So the gradient of L2 should be 5 over 3. Remember that we flip and we change the sign. And then in order to find the equation of the straight line, I'm using that y minus y1 is mx minus x1. So y minus minus 2 is 5 over 3 x minus 6. This means that y plus 2 is 5 over 3 x minus 6, like that. I will cross multiply. 3y plus 6 is 5x minus 30, expanding on the right hand side, which means that 3y is 5x minus 36. And if I divide throughout by 3, I get y is 5 over 3 x minus 12. I had to give my answer in the form y cos mx plus c, so be careful to match the form of the answer requested. Question 4, we've got the straight line here, we've got the vertical line here, L2, and we've got the parabola 2x minus a half x squared. So the line L1 has equation 2y is x. So I could write the equation next to L1, 2y is x, which means y is x over 2. The parabola is y is equal to 2x minus a 1 over 8x squared. We're being asked to determine the inequalities that define this region here, R. So I will start by finding the equation of L2. Now L2 has an equation of the form x equals to a number. I need to find this number. which is just the cut here on the x-axis. So I will start by setting this equal to 0 because it's a cut on the x-axis. I put y 0. So 2x minus 1 over 8x squared is equal to 0. I will factor out the x. I get x brackets 2 minus 1 over 8, x is 0. So either x is 0 or 2 is equal to 1 over 8 x, which means that 16 is equal to x. So L2 is the line with equation x equals to 16. Now I want to be to the left side of this, and this is a dotted line, which means it's a strict inequality. So we want the x to be less than 16. Looking at L1, we want to be below this, and it's a solid continuous line. So we want y to be less than or equal to x over 2. And for the parabola, we want to be above this. So I want y to be greater than or equal to 2x minus 1 over 8x squared. In question 5, we're being given the graph of cos 2x, x is in radians, and we need to state the coordinates of P. This is the minimum point here. Before I determine the coordinates of P, I need to consider what kind of transformation cos of 2x is compared to cos of x. So we've got y is cos of 2x. This is a stretch along the horizontal, scale factor over half, which means divide all x values by 2. We know that the original cosine wave has a minimum at pi comma minus 1, which means that if I divide the x values by 2, it means that the coordinates of P should be pi over 2 comma minus 1. In part B, we're being asked to sketch y is equal to sine x on the diagram shown here. So y is sine x will be something like this. So let me draw this and I will explain exactly on what's happening. Because we need to be careful, we've got the right maxima and minima in order to qualify for the full marks. I also need to draw this part here. So let's see what we've got here. This is the graph of sine x. I'm just gonna label this. So we knew that this point P was pi over 2 comma minus 1. We know that sine of x is 0 every pi. So this is pi, 2 pi, 3 pi, and so on. The maximum is 1, the minimum is minus 1. So this is what the graph should look like. In part C, it says hence or otherwise deduce the number of solutions of the equation cos 2x is sine x in the region of 0 to 20 pi. So if I just concentrate on this region here from 0 to 2 pi, just to see on what's happening in the first 2 pi, we see that we've got 1, 2, 3 points of intersection. So we can simply say that in a region that spans 2 pi, we've got 3 solutions. So from 0 to 20 pi, that's gonna be 10 times that, so it's gonna be 30 solutions. Now in II, we have to go from 0 to 21 pi, which means that we've got the 30 solutions and then the extra solutions in that extra pi, which is simply any solutions that we see here. So if we check carefully, from 2 pi to 3 pi, we've got 2 extra solutions. So it's gonna be 30 plus 2, which is 32 solutions. So once more, I tried to see on what's happening in the first 2 pi. Let me show you again here on what's happening. So this is the first 2 pi that we've got. So in this first 2 pi, we've got 1, 2, 3 solutions. So every 2 pi, we have 3 solutions. So in a range of 20 pi, we'll have 10 times the number of solutions. So it's gonna be 30 solutions. And then from 0 to 21 pi, we've got the extra 1 pi at the very end. So there it is. So once more, this is what we have. So in that extra 1 pi, we've got this solution and this solution. So 2 more solutions. That's why we get the 32 solutions. In 6, we need to solve the equation f dash of x is 0. We have f of x here, so I will start by differentiating. I get the power down, so 2 times 5 over 2. 2 times 5 over 2. I deduct 1 from the power to the 3 over 2 minus 40. So this is 5x to the 3 over 2 minus 40, which I set equal to 0. So 5x to the 3 over 2 is equal to 40, which leads to x to the 3 over 2 is 8, and therefore x is 8 to the 2 over 3, which is equal to 4. In B, we need to solve f dash dash of x is 5. So I will start by finding the second derivative, f dash dash of x. I will differentiate the first derivative. So once more, get the power down. So 5 times 3 over 2, deduct 1 from the power, which simplifies to 15 over 2x to the power of a half. And I will set this equal to 5. Now, I will cross multiply. 15x to the half is 10. X to the half is 10 over 15, which of course simplifies to 2 over 3. And therefore x is simply 2 over 3 squared, which is equal to 4 over 9. In question 7, we've got this figure here showing the design for a structure used to support a roof. Now we know that AB is 6.5 meters, BC is 4.7 meters, and BD is also 4.7 meters. I like to add the information on my diagram, and we need to find to 1 decimal place the size of angle ACB. So this angle here, which I will call theta. Now I'll be using the sine rule here, and I will simply say that sine of 35 over 4.7 is equal to sine of theta over 6.5. So 6.5 sine of 35 over 4.7 is equal to sine of theta, which means that theta turns out to be 52.4897. Now we need to be careful here because this particular scenario here is actually the ambiguous case of the sine rule. This does not look like 52.5 degrees. It's actually this angle here, that's 52.5, because we've got 2 triangles that satisfy all the given information, that this angle here is 35 degrees, and this is 6.5, and this is 4.7. So we know that sine of theta and sine of 180 minus theta are equal, which means that actually the angle I'm after, ACB, is 180 minus 52.4897, which turns out to be 127.5, correct to 1 decimal place. So theta here was actually 127.5. Now, part B, we need to find the total length of wood required to make this structure. So we've got 1, 2, 3 lengths. We've got this. We need this here. So what we could do is find the angle ABD, which will simply be 180 minus 35 plus 52.5, which turns out to be 92.510289. Notice that I'm using full accuracy throughout the working out. I'll be using the cosine rule to find AD and then simply add everything up. So in B, I will say that AD squared is equal to 6.5 squared plus 4.7 squared minus 2 times 6.5 times 4.7 times the cosine of 92.510289. Plug everything on the calculator, take the square root, I get 8.19 meters. So for the total length, I will simply be adding up the 6.5, the 4.7 and the other 4.7, and the value I just found, the 8.19, which is 24.086, which is 24 meters to the nearest meter. In question 8, we are being given f of x here. It has a single turning point at 4,9. It cuts the y-axis at 0,6 and the x-axis at minus 3,0. It has an asymptote at y is equal to 4. And it says, state the equation of the asymptote to the curve with equation y is f of minus x. Now, f of minus x means all the x's get multiplied by minus 1. So it's a reflection along the y-axis. So if I'm reflecting along the y-axis, we said that the x's get multiplied by minus 1, but the y's remain unaffected. So the asymptote will still be at y is equal to 4. In B, we need to state the coordinates of the turning point for f of a quarter x. So if we have y is equal to f of a quarter x, then the transformation is a stretch along the horizontal, scale factor of 4, which simply means that we are multiplying the x's by 4. So if I'm multiplying along the x's by 4, it means that the original turning point at 4,9 will now be found at 16,9. The y remains unaffected. In part C, the line y equals to k intersects C at exactly 1 point, and we need to state the possible values for k. Now, y is equal to k. I could draw a horizontal line. It's a horizontal line, y equals to k, and we could just look at the number of intersection points with the curve. Now we've got 2. If I take it upwards, when it passes through the maximum, it's just 1 intersection point. If it goes higher above, there are no intersection points. Again, if I go down, we are at 1, 2, 2, 2, 2. The moment I sit on the asymptote, it's going to be just 1 because it's only this point here. There is no intersection with the asymptote because the curve here will not touch the asymptote. So any values that are below or equal to the asymptote will give me 1 point of intersection, which leads me to conclude that I will either be less than or equal to 4 or equal to 9 to go through the maximum point. So my values for k that lead to 1 intersection point only will be k is equal to 9 or k less than or equal to 4. And then D, the curve C is transformed to a new curve passing through the origin. If we have f of x minus a, we need to state the value of the constant a. Well, f of x minus a simply means that I have translated my original curve a downwards. So let me show you exactly on what's happening. I take my curve and I go a down. So if I go a down, then this simply means that I have translated by 6 units downwards. So it must be the case that a is 6. So the value of a must be 6, which means taking it down by 6 units has taken this transformed curve to go through the origin. So in CI, a must be 6. Then in II, we need to write down an equation for another single transformation of C that also passes through the origin. So another way would be to actually take the curve and instead of shifting it up or down, we will translate it left or right. So I could take the curve here and go to the right so that it sits here. This means I need to go 3 units to the right. We know that the translation 3 units to the right is one of the 4 y is equal to f of x minus 3. So 3 units to the right. Number 9, we've got this equation here. C is a constant, it has no real roots. We need to find the range of possible values of C. So let me start by writing out the equation given to me. It makes sense to get rid of the fractions. I'll multiply everything by x. It leads to a quadratic in x. I'll collect everything on the left-hand side. Plus 5x minus 6 minus cx plus 3 is 0. So we're looking at a quadratic for which we have no real roots. This means that the discriminant should be less than 0. So if the discriminant is less than 0, this means that b squared minus 4ac should be less than 0. Even though you might be tempted in expanding this bracket here, I will actually leave it as it is. It will make the solution easier to obtain. 5 minus c squared minus, well, 4 times 2 times 3 is 24, less than 0. So 5 minus c squared less than 24. I will find the critical values now, and the critical values will be obtained by turning this inequality into an equation. So I have 5 minus c is plus minus the root of 24. So 5 plus minus root of 24 is equal to c. It's a quadratic inequality which we always solve graphically. I will draw my parabola. It's a smiley parabola because if I expand this, the coefficient of c squared will be 1, which is positive. The critical values will go on this sketch, 5 minus root 24 and 5 plus root 24. We go plus, minus, plus, and we want to be less than. We want to be negative. So we want to be here. So we choose the inside region. So 5 minus root 24 less than c less than 5 plus root 24. It's the range of possible values for c. In 10, we've got a sector of a circle, center O, radius r, angle is theta, it's in radians, and we are being given that the area is 6 square centimeters and the perimeter is 10 centimeters. And we need to show that 3 theta squared minus 13 theta plus 12 is 0. I draw a quick sketch just to have a graphical illustration of what's happening. We know that since the angle is measured in radians, the area is given by a half r squared theta. So 6 is a half r squared theta, which leads to 12 is r squared theta. On the other hand, the perimeter is 10. Well, the perimeter is the 2 radii plus the length of the arc, which is given by r theta, since theta is in radians. So 10 is 2r plus r theta. I will factor out the r and make r the subject of the formula, because I need to combine these two equations, the one derived from the area and the one derived from the perimeter, in order to end up with one equation in one unknown theta. So in the place of r, I will be putting 10 over 2 plus theta must be squared times theta. So 12 is 100 theta over 4 plus 4 theta plus theta squared. I will simplify the 12 divided by 4 is 3, and 100 divided by 4 is 25. And now we'll cross multiply to obtain that 12 plus 12 theta plus 3 theta squared is 25 theta. So 3 theta squared minus 13 theta plus 12 is 0 as required. In part B, it says, hence find the possible values for r and theta. Now I will start by solving this quadratic. It can be solved through factorization. 3 theta minus 4 theta minus 3, which means that either 3 theta is 4 or theta is 3. Now we have theta is 4 over 3, and I can now proceed by substituting theta here to get the value of r. So if theta is indeed 4 over 3, then r will be 10 over 2 plus 4 over 3, which turns out to be 3 centimeters. If theta is 3, then r is 10 over 2 plus 3, which is 2 centimeters. In 11, we need to sketch the graphs of x3 minus x and x minus 2, 5 minus x, showing clearly cuts on the coordinate axis. So with these type of questions, I like to write down a few things that I know for sure. So we start with y is x3 minus x. It is clear that if we expand, we get a negative quadratic, so the shape will be a sad face. It's gonna be something like this. It's in a factorized form, so when y is 0, x is 0 or x is 3, which means we've got the cuts on the x-axis. It's gonna be something like this. So we will be having cuts at 0 and 3, and that's y is equal to x3 minus x. On the other hand, we've got y is x minus 2, 5 minus x. Notice that if we expand this, it's going to be a cubic, of course, with a negative leading term. It's going to be minus x cubed. So the shape will be something like this. Again, when y is 0, we get x is 0 or 2 or 5. So I could actually sketch this. It's gonna be something like this. So it's a cubic. So it's cutting at 2, it's cutting at 5. It's y is x minus 2, 5 minus x. So this is the sketch we were after. And it says, show that in part B, show that the x coordinates of the points of intersection of the two curves satisfy this equation here. So points of intersection simply means put one equal to the other. So we've got x brackets 3 minus x is equal to x brackets x minus 2 brackets 5 minus x. I will just expand everything. 3x minus x squared is x brackets 5x minus x squared minus 10 plus 2x which is x 7x minus x squared minus 10, which can be further expanded into 7x squared minus x cubed minus 10x. I will collect everything on the left hand side, so I have x cubed minus x squared minus 7x squared plus 3x plus 10x is equal to 0. So x cubed minus 8x squared plus 13x is 0. I will factor out the x and I get x brackets x squared minus 8x plus 13 is equal to 0, which is exactly what I had to show. So as required. And in C, point P lies on both curves. Given that P lies in the first quadrant, well, if P lies in the first quadrant, it means that its x coordinate is greater than 0 and its y coordinate is greater than 0. We need to find, using algebra and showing the working, the exact coordinates of P. So I will start by solving this. Obviously, the x being 0 is not an interesting solution because it's just the origin. So I have to solve x squared minus 8x plus 13 is equal to 0. I'll be using the quadratic formula for this one. X is minus b plus minus b squared minus 4ac square root of that over 2a. This leads to 4 plus minus root 3. If I just revisit for a moment my sketch here, I got 2 points of intersection. One is here and the other is here. Obviously, P is this one here, which lies in the first quadrant. So its x coordinate will be 4 minus root 3. And here it's gonna be 4 plus root 3. So when x is 4 minus root 3, y, well, to find y, I will substitute it into the simplest of the two, this one here. It's gonna be 4 minus root 3 brackets 3 minus 4 minus root 3. So I'm replacing x with 4 minus root 3. I need to show the working because it was explicitly stated in the question that they want to see the working out. So I will expand. It's minus 4 plus 4 root 3 plus root 3 minus 3, which is equal to minus 7 plus 5 root 3. And therefore, the coordinates of P will be 4 minus root 3, comma, 5 root 3 minus 7. 12, we're being given the y, the x, and we need to find the equation of the tangent to the curve at the point P with coordinates 4 minus 2. So I will start by evaluating the derivative. This will give me the gradient of the tangent at x is 4. So it's going to be 3 times 4 times root 4 minus 10 times 4 to the minus a half. Put everything on the calculator, we get 19. For the equation of the tangent, I'm using y minus y1 is mx minus x1. In the place of y1, it's going to be minus 2. In the place of m, it's 19. In the place of x1, it's 4. I will expand because I need to give my answer in a particular form. It's 19x minus 76. So y is 19x minus 78, the equation of the tangent. And then part B, we need to find f of x. Well, we've got the derivative, so if we integrate, we will be finding an expression for f of x. So I will integrate 3x root x minus 10x to the minus a half dx. I will first put it in the form that allows me to do the integration. So I write the root x as x to the a half. And I will actually further proceed into writing this as the integral of 3x to the 3 over 2 minus 10x to the minus a half dx. And I'm now ready to integrate. I increase the power by 1. and divide by the new power, 5 over 2, minus 10x to the half over a half, plus c, do not forget the c. This can be simplified into 6 over 5 x to the 5 over 2 minus 20x to the half plus c. We have been told that when x is 4, y is negative 2, which means that minus 2 will be 6 over 5 times 4 to the 5 over 2 minus 20 times 4 to the half plus c. This leads to minus 2 is minus 8 over 5 plus c, and therefore c is minus 2 over 5. The only thing that's missing is for me to write out the full equation. F of x is 6 over 5 x to the 5 over 2 minus 20x to the half minus 2 over 5 to complete the answer.